Hello, welcome back to Voxel Heist, a tutorial series that I intend to be doing weekly for the rest of 2026. This episode will be looking at C# Basics, which is the coding language that we'll be using within Unity. Before we get started, last episode we looked at lighting and materials, and I set you all a task. Here is the solution to said task. So for the capsule, it was to set its position to 222 and its rotation to 45, 45, 45. And here it is. All you have to do is go to the transform, look at its position and rotation, and set them all to 2, and set the rotation to 45, 45, 45. Now with the material, all we had to do was create material. I'll call this example. And we click on the base map color picker here. And in the hexadecimal at the bottom, I set it to 1, 2, 3, 4, 5, 6. Get that blue. And set smoothness to 0. Then it was drag and dropping it onto the actual capsule itself. So I'm going to remove that along with the materials that we're not using. Guess we were using that one, but it's fine. What I can do is go to our floor. See, materials missing because I've deleted it. Click on this little dot in the right hand side and just click on the Unity's, and we're back. Sorry about that. I was unable to actually find the material, which was a bit unexpected, but it's fine. I just made a new material and applied it to our floor. Up until now, we've been working entirely inside the Unity editor, but everything that moves or I guess thinks or reacts in the game is driven by code. In this episode, we'll be learning the basics of C#, the programming language Unity uses. But don't worry if you've never coded before. Today is about understanding ideas, not memorizing all of the syntax and the code. By the end of this video, hopefully, you'll know what a script is, how variables store information, and how methods or functions let your game do things. So to begin with, you'll be installing your IDE of choice. This is your interface where you're able to type your code. I use Visual Studio Community. Here you should be able to see the webpage of Visual Studio and where you can download it from. I'll also be showing the packages or the add-ons that you'll most likely need to have it interface with Unity. And finally, once you have installed it and it's set up, so feel free to pause and take a moment to sort that all out, we go to Edit, Preferences, and you'll see External Tools. Here, this is where you'll select Visual Studio, and hopefully that should be all sorted for you. Unfortunately, I set up all of my settings and things a long time ago, so I won't be able to know exactly if this works immediately for you. I'll ask for feedback and get help, and if it's not straight away working for you, I'll edit in me showing you how to fix issues that may arise. But to carry on, we are going to be writing our first C# script. So what I'm going to do is go to our main assets folder, right click and click on, well, firstly I'll make a folder. This is where our scripts are going to lie. And I'm going to create a Monobehaviour script. And I'm going to call this player controller. One thing you need to be aware of is you cannot have spaces in the names of these scripts. Hence why I've done it in all in one word. On the right hand side, you'll be able to see a, I guess, preview of what our script has in it to begin with. To begin with, it has default functions that are put in on script creation. So you can see that we have words in here like using Unity Engine, public class, the name that we called it, Monobehaviour, start, update, void, and these curly brackets. We'll get into what all of this does momentarily. But to test if everything has been set up correctly, we'll double click on our player controller and it will open Microsoft Visual Studio. A script within Unity is just a C# file. It is, again, the file that contains all of our code. Later down the line, we can attach our code onto our player object, our game object in the game that represents our player. Unity works with something called components that we've gone over in previous episodes. So a game object is basically an empty shell. It does nothing on its own. But when we add components to it, like scripts and our mesh renderer, or lighting, we're able to give it different abilities that it can do. So the script doesn't do anything yet, but now we can program our player. At the top, you'll see using Unity Engine. This gives us access to Unity's built-in tools. If we didn't have it, we wouldn't be able to interface with Unity. This line here, public class player controller, Monobehaviour. A class is a blueprint. It is defining what our player controller is. Within a class, you're able to have different functions, variables, and other things that we'll get into shortly. Monobehaviour in this line is very important. It tells Unity that the script can be attached to a game object and it can receive events within Unity. Everything between these curly brackets here belongs within this class. Again, as a default, all of this is created when we make our script file within Unity. So within here, upon making this, it populates the script with this. Void start, I guess we'll begin with. As you can see, it also comes with its description. Start is called once before the first execution of update after the Monobehaviour is created. What this means in plain English is when the game starts and this is active, whatever code is in here will run, and then for every frame of the game afterwards, so you know the term frames per second, for every frame afterward, update gets called. Update is called once per frame. But we are going to get rid of these for the moment, and we're going to focus on the different parts of C# that are very useful tools for us. So we're going to go over a few things. So I guess I'll just get to work and describe what I'm doing. I'm doing 2 forward slashes to denote a comment. This area is going to be our variables. You can see with my Unity, my Visual Studio setup, it gives me predictive text. So it's very good in understanding what I will either want or it expects from me in the script. So I can understand that this is a player controller and that by default a player would have a move speed, which is what this is telling me here. So to begin with, we'll do public. I will say int health 100. For me, typing it out quickly, at this point, you can see it has the predictive text. I just press tab on my keyboard to autofill, but I think I might refrain from doing that. So health equals 100 semicolon. I'll go through what some of this means, and I'll go into the different public and private names shortly. Int is short for integer. An integer, if you remember from maths class, is a whole number, hence 100. But if I did 100.10, you can see that we get a red squiggly line. This is denoting that there is an error within our code. Cannot convert type double to an int. What this is telling us is that this number here isn't a whole number. It's defined differently within our code base. So I can remove that and we can get on to the next one. This one is going to be, I love how it already knows, float a decimal number value. So we'll do public float move speed, and we'll say that this equals 5.5 semicolon. But you can see that we've identified that is a float or a floating point number, a decimal number value. We've said that it's a float. Remember, it goes our access name. I'll call it that. I don't believe it is actually that. Give me a sec. Public and private, which we'll get into shortly, are the access specifiers. So they denote where they can be accessed from. But again, we'll get into that. So we've identified it as a float or a floating point number. We've given it a name and we've said that it equals 5.5, but we still have an error. This is because we need to use a suffix, which is a lowercase f, to identify it as a float. F for float, floating point number. Let's see if it knows. It knows. Boolean, a true or false value. So we'll say public bool. This is the short keyword. A bool can either be true or false. So in this instance, we'll say detected for our stealth game, and we'll say false because they don't begin detected. Otherwise, that'll be a very short game. Lastly, a string is a sequence of characters. So I'll say public string player name. A string is identified as quotation marks, which is should be above your 2 key on your keyboard, but that is on a UK keyboard. We're going to say Alex. The Heist man. Currently name in progress. But a string is able to store text that we can set and refer to later on. With these 4 things, an int, a float, a bool, and a string, these are To be honest, the foundation building blocks for a C# script. These working in tandem with functions or methods, they are very powerful as to what they allow us to do. However, I'm going to set move speed to private, and you can see it gets grayed out. So, public, as I said, is an access specifier. What that means is I'm going to Control S to save, head back over to Unity. It will take a moment to compile the script, but you can see it's updated there. And I'm going to go to our player, drag and drop our script onto the player. Now you can see health is at 100, is detected, is false. This is if it were true. And the player name is Alex the Heist Man. However, that's only 3, whereas we made 4 variables. This is because I've set it to private. Private means that it can only be accessed from within this script. Public means that it can be referenced from any other script within our project. If you've seen other Unity tutorials before, you'll see that there is a way to make a private variable public within Unity. But again, this is just an example. I'm not going to go too much detail into this because it's not something we'll be looking at incredibly much. But if I save, you'll see that this is still a private variable. It won't be able to be accessed through different scripts. However, if we put the tag serialize field, it forces Unity to recognize it. So now if I go back to Unity and click on us, or our player, we will see the move speed. It's 5.5. There are many different short hacks and tricks that you can do within C#, but I'm just going to keep it basic for us to get to learn. I'll probably throw a few of the tricks like serialize field in later down the line, but again, I'll go into those more detail once we have a decent understanding of C#. We're now going to be looking at methods. Again, I call them methods or functions. To me, they are one in the same. To create a method, we need to type what, firstly, it will return. So, for example, if I wanted to make a method that returns a whole number or calculates a number for us, I could type int because I want it to return an integer. You can see how it's setting up stuff later on. But I'm going to say get player health. And you can see how it, again, wants to complete it for us. But this is the name of my function. However, in order to denote it as a function, you need 2 normal brackets at the end. You'll see why in a moment. And we'll also need 2 curly brackets, as they will hold the code for this function. So, for get player health, I'm going to say I would like it to return health, as that is the value that's been set up here. However, you can see that our script, or our method, sorry, is grayed out. This is because this will also take an access specifier. So if I do public, you'll see that it is now in full color. However, as a default, if you don't type anything, same with if I say string, it becomes private as a default. But for our example, keep things public, which, to go in depth on the differences between private and public, as we have done earlier, private is more sort of secure in terms of scripting. So what I'm going to show next is, funnily enough, something along the lines of this. I'll do public void, So void in place of an int because it won't return anything. It will do something within the script and then just carry on. So I will say set player health, 2 closing brackets and 2 curly brackets. However, within the brackets at the end of the function, in here I can type a variable. Remember, we've got int, float, bool, and string. A variable that will be passed into the function. So I'll say to add. So let's say our player gets a health potion. Okay, I'll say heal player then. We'll say that our player gets a health potion or something, and we want to increase our health. So what we can do is health equals our current health plus to add. And there we go. If we follow the logic of this, this is where we get into the mathematics side of programming. Somewhere we would run a function called heal player. And I can create start quickly just to show it. So heal player, you see that upon typing, it can recognize basically everything within our code base that has the word heal in it, or HEA. And if I do heal player, you can see it defaults to this one and gives us a description of what the method does, what is. Press tab to autocomplete, brackets, and a semicolon. With heal player, you can see that it's giving us an error because we haven't given it an int within these brackets. So we're going to say 5. So what this is now telling us is at the start of our game, remember, when the game starts, we want to heal the player for 5. This doesn't have to be called heal player. It's purely because I have chosen that as a name and I have defined it here. So heal player, and we pass in the number 5 into here, which becomes a variable, the variable called to add. Then within heal player, we can see that health plus to add, so the number that was passed in, so 5, now equals health. So for this, it would look something like, what do we say? 100. 100 equals our health plus our to add, which is 5. So then our health becomes 5. Oh, sorry, 105. And then it'll just carry on through the script. So then if I were to do get player health, and I'm going to Control D to duplicate the line, and Alt up arrow to move the function up 1. So at the start, it would return the number of our health, which is 100. We'd heal the player by 5, so increase their health by 5, and then get 105 returned here. This isn't returning the health anywhere. All we're doing is calling this, but we're not sending the information it gets anywhere. A thing that we can do is create a new method or function. I'm going to call this print player info. And what I'm going to do is an easy way to print to, if we go over to here, our console within Unity. This is where we have our errors and our messages and our warnings, as you can see, this one, because we currently have a warning of move speed has been created but it's never used anywhere. We'll get to that in a moment. But we're able to send our own messages to that text area. We can do that by doing debug full stop or .log. Now we're able to type things within here. So this is a debug message in the console. Control S to save. So what we can do is debug.log. I'm going to do the player colon. I'll do this and say what it translates to. So, I'd like you to first look at this debug.log here and tell me, or think to yourself what you think this does. Okay, so I can tell you what this will do is in the console log, so it will log a message to the Unity console, it will say this: the player colon the player name, so the player Alex the Heistman is at, and it gets the player health, which returns the health, so we'll say 100. So the player Alex the Heistman is at 100 health. And what we can do is remove this line and remove this line. And we could actually run this to see our message within Unity. So back to Unity. However, nothing's happening. Like we can see our script is on there, on the player, but nothing's happening in our console. That's because we haven't started the game yet. To do that, press the start or the play button at the top. It will execute everything, and then you'll see that our console has been spammed with this is a debug message in the console. The player Alex the Heistman is at 100 health. This is a debug message in the console. The player Alex the Heistman is at 105 health. And that's because we called it twice. Get rid of this line and yeah, get rid of print info. And I think on start we will just say debug.log. We are able to do different debugs. For example, error. This is one that will print in red. The game has started. Now look at the update function. So private void update, curly brackets. Ooh, did that for us. We will now do to demonstrate what the debug update. Oh, sorry. We'll now demonstrate what the update does by saying update running, and you'll see that debug.log takes a message or a string. Again, this is identified by the quotation marks. So heading back over to Unity, you can see our console. If I press play, we will get one error, and we are spammed every frame that the update is running. I can clear the console by just pressing clear. So to reiterate, start runs once the object is created or the game starts. with it being active, and update runs every frame. So it could run up to 60 times per second or higher. Anything that needs to happen constantly goes into update, but we need to be careful not to overload it, as it could really, really slow down the game. I will say a few common mistakes that can crop up. For example, semicolons matter. So at the end of a function or a line of code, we need to put a semicolon as an end line, essentially, telling the script that, okay, we've done this, it ends there. Great. However, it's only in some places, I guess, as you don't really put them at the end of a function. But you'll be able to work it out if, again, I had done this. You can see that it is an error, which is perfectly fine. Capital letters matter. So in terms of syntax, if I did this as a ball, you can see that it's not correct because in the code it is written specifically as a lowercase b. I do the same with string, same thing. Also, for example, with the same with public, and yeah, capitalization or lowercase very, very much matters. If I do save this with an error and head over to Unity, you will see that we have an error and it's telling us such within our console. If I try to play, we can't play because we need to fix all of the errors within our code. So a handy feature is I can look at the console, I can double click the error, and it will take me to it within Visual Studio. So if I go up here and click on the help there, you can see it's taken me back down to here. I fixed the line. It reloads and recompiles all of the scripts and gets rid of the error. I'll also change this back to public, because I want to get rid of that warning. But yeah, it's a case of if you make a typo, it's fine. You have all of these resources like the console and having it within Visual Studio telling you where the errors are, and it's perfectly normal. It's a part of learning, it's not a failure. Today, we have learned what scripts are, variables that can store data, and how methods or functions are able to control what things happen within our game. Next episode, we'll look into learning how code makes decisions using if statements, loops, and enums or enumerators. But again, we'll get into that there and then. I, however, am going to set you some homework for this episode. Back in a sec. Okay, welcome back. You can see that our player controller has changed somewhat. Player name is now Matty, the coding helper, and amount of tutorials made are 2. If I press play, you can see that in our console, we have hello Matty, the coding helper. You have created 2 tutorials. If I stop the script and go and change this to 3, press play. Hello Matty, the coding helper, you've created 3 tutorials. I would like you to see if you're able to do this within your script. I wish you the best of luck. And again, thank you all so much for watching. In the description, we have a link to my website, transformingpanda.co.uk. We have a link to my coffee. So if you're willing or able to support, you can buy me a coffee and I would appreciate it very much. We also have our Discord, which should be set up by now, hopefully. And I think that's it for the stuff in the description besides the chapters. Thank you all ever so much for watching again. Feel free to give us a subscription and a like, as it really helps with making these tutorials. So with that, we'll be back, as I said, next week to look at some more coding and see how we can make decisions within our code. Thanks for watching.